In this Tryhackme room today, we got intro to cross-siting scripting. It's gonna be a red teamer room. It's a easy room, and it is on web fundamentals for the pen testing path. Room brief. I already did some of it, but I haven't finished it yet. So just restart from the jump. Give me a refresher, anyways. It's worth noting that because XS is based on JavaScript, it would be helpful to have a basic understanding of the language. However, none of the examples is overly complicated. Also, a basic understanding of client-server requests and responses. Cross-site scripting is better known as XSS in the cybersecurity community. Is classified as an injection attack, where malicious JavaScript gets injected into a web application with the intention of being executed by others. In this room, you'll learn about different XSS types, how to create XS payloads, how to modify payloads to evade filters. Then with practical lab where you can try out a new skill. All right. Cross-siting scripting vulnerabilities are extremely common. All right. You get paid very well for finding and reporting these vulnerabilities. What does XSS stand for? Cross-site scripting. All right. XSS payloads. What is a payload in XSS? The payload is JavaScript code we wish to execute the target computer. There are two parts of the payload: the intention and the modification. The intention is what you wish the JavaScript to actually do, which we'll cover with some examples below. The modification is the change to the code we need to make it execute. Every scenario is different. More on this in perfect payload task. Here are some examples of XSS intentions. Bro, let me just say fucking cross-siting. Proof of concept. This is the simplest of payloads where all you want to do is demonstrate that you can achieve cross-siting on a website. This is often done by causing an alert box to pop up on the page with a string of text, for example. So script alert. All right, so just some, all right, just some JavaScript there, I think. Session stealing. Details of user sessions, such as login tokens, are often kept in cookies on the target machine. The below JavaScript takes the target's cookies, base64 encodes the cookie to ensure the success transmission, then post it on a website under the hacker's control to be logged. Once the hacker has these cookies, they can take over the target session and be logged as that user. All right. Keylogger. The below code acts as a keylogger. This means anything you type on the web page will be forwarded to a website under the hacker's control. This could be very damaging if the website payload was installed on accepting users' login or card details. Business logic. The payload is more specific than the above example. This would be calling about a particular network resource or a JavaScript function. For example, imagine JavaScript function for changing the user email address is called user change email. Your payload could look like this. So we have script user.change email. Then now that email address for the account has changed, that attacker may perform a reset password attack. The next 4 tasks are going to cover different types of cross-siting vulnerabilities. All require slightly different attack payloads and user interactions. Which document probably could contain the user session token? If you go look for it, well, it's document.cookie. Has these cookies. Yeah, right here, document.cookie. And then which JavaScript method is often used as proof of concept? Alert. Be alert. I mean, I already did it, but I'm not sure where I found it. I found it though. Y'all can pause it. Reflected cross-siting. Reflected cross-siting happens when users supply data and an HTTP request is included in the web page source without any validation. Example scenario: website where enter incorrect input and error message is displayed. The content of the error message gets taken away from the error parameter in the query string and is built directly into the page source. The application doesn't check the contents of the error parameter, which allows the attacker to insert malicious code. The vulnerability can be used as per scenario in the images below. Invalid input detection. So 1. Attacker sends link to victim that contains malicious payload. 2. Victim clicks links, right? 3. Link containing attacker script is executed on the website. 4. The data the attacker script gathered is sent to them that could steal victim's cookie, which would allow attacker to take over victim's account. The attacker could send links or embedded into iframe on another website containing JavaScript payload to potentially victims, getting them to execute code on their browser, potentially revealing sessions or customers' information. How to test reflected cross-siting. You'll need to test every possible point of entry. These include perimeters in the URL, query string, URL file path, sometimes HTTP headers, although unlikely exploitable in practice. Once you've found the data which is being reflected in the web application, you'll need them confirm they can successfully run JavaScript payload. Your payload will be dependent on where the application, your code is reflected. You'll learn about this time. Where in a URL is a good place to test for reflected cross-siting. In the perimeters, reflected. Content gets taken from the error perimeter. The content of the error message gets taken from the error perimeter. So that's where you find the answer right there. And it's perimeters. Stored cross-siting. As the name infers, the cross-siting payload is stored on the web application and database, for example, and then gets run when other users visits the site or the web page. Example scenario: a blog website that allows users to post comments. Unfortunately, these comments aren't checked for whether they contain JavaScript or filter out any malicious code. If we now post a comment containing JavaScript, this will be stored in the database, and every other user now visiting the article will have JavaScript run in their browser. So attacker inserts malicious payload in website database. For every visit to the website, the malicious script is activated. Victim, the data the attacker script gathers sent to them, they could steal the victim's cookie, which, okay, so this is pretty stored cross-siting, so this one's stuck in there. So this one's worse than reflected, for sure. I see. It's like pretty much spawn camping in there. The malicious JavaScript could redirect users to another site, steal the user's session cookie, or perform other website actions while acting as a visiting user. How to test for stored cross-siting. You will need to test every possible point of entry where it seems data is stored and then shown back areas that others have access. And a small example of these could be comment on a blog, user profile information, website listings. Sometimes developers think limiting input values on the client side is good enough protection. So charging values to something on the web application would not be expecting is a good source of discovering stored cross-siting. For example, an age field that's expecting an integer from a drop-down menu, but instead you manually send the request rather than using a form allowing you to try malicious payloads. Once you've found some data which is being stored in the web application, you need to confirm that and you can successfully run your JavaScript payload. Your payload will be dependent on where in the application your code is reflected. You will learn how are stored cross-siting payloads usually stored on website and the database. DOM based cross-siting. What is DOM? DOM stands for Document Object Model and is a programming interface for HTML, XML documents, and it represents the page so that the change of the document structure, style, and content. A web page is a document. The document can either be displayed in the browser window or as the HTML source, and a diagram of the HTML document object model is displayed below. So if we look at the model here, document, root element, HTML, element head, element title. If you go to the page source, you can pretty much, not the page source, Yeah, inspect. If you go to inspect element, you can pretty much see this, what it's showing. If you want to learn about DOM and gain a deeper understanding, W3org has a great resource. Check that out if y'all want to. Exploiting the DOM. DOM based XSS is where the JavaScript execution directly happens in the browser. I wonder if it gets flagged. Try it out. I don't know. Never mind. Let me not. DOM. Fuck. Is DOM-based cross-sighting is where JavaScript executions happens directly in the browser without any new pages being loaded or data submitted to the backend code. Wait, let me read that again. DOM-based cross-sighting is where the JavaScript execution happens directly in the browser without any new pages being loaded or data submitted to the backend code. Okay, so it doesn't affect the backend. Execution occurs when the website JavaScript code acts on input or user interaction. Example scenario: the website JavaScript gets the content from Windows location hash parameter, then writes that onto the page in the current being viewed in the section. The contents of the hash aren't checked for malicious code, allowing an attacker to inject JavaScript of their choosing onto the web page. Potential impact: craft links could be sent to potential victims, redirecting them to another website. So content, of course. How to test for DOM-based. DOM-based cross-sighting can be challenging to test and requires a certain amount of knowledge of JavaScript to read the source code. You need to look for parts of the code that access certain variables that an attacker have control over, such as Windows location parameters. When you found that those bit of code, then you need to see how they are handled and whether these values are ever written to the web page. Is DOM pass unsafe JavaScript methods such as eval. What's an unsafe JavaScript method is good look for? What unsafe JavaScript method is good look for in source code? Evil. Right. All right. So we get blind cross-sighting. Blind cross-sighting is similar to stored cross-sighting, which we cover in task. In this payload, you get stored on the website. You get stored on the website for another user to view, but in this instance, you can't see the payload working or be able to test it against yourself first. Example scenario: website has contact form where you can message a member staff. The message content doesn't get checked for any malicious code, which allows the attacker to enter anything they wish. These messages then get turned into support tickets which staff view on a private web portal. Right? Potential impact: user correct payload. The attacker JavaScript could make calls back to attacker's website, revealing the staff portal URL, the staff member's cookies, and even content of the portal page that is being viewed. Now the attackers could potentially hijack the staff member's session and have access to the private portal. How to test for blind cross-sighting. When testing blind cross-sighting vulnerabilities, you need to ensure your payloads has a callback, usually HTTP request. This way you know and when your code is being executed. A popular tool for blind access cross-sighting attacks is cross-sighting Hunter Express. Although it's possible to make your own tool in JavaScript, this tool will automatically capture cookies, URLs, page contents, and more. What tool can you use to test for blind cross-sighting? It's going to be the cross-sighting Hunter Express. What type of cross-sighting is very similar to blind? Isn't it stored? It's going to be stored cross-sighting. All right, now we get to some fun stuff. Gonna actually have some work to do here. Start the machine up. It's gonna take about 2 minutes. Get the machine started real quick. The payload is the JavaScript code we want to execute and either on another user browser or as proof concept to demonstrate vulnerability in a website. Your payload could have many intentions. Just bringing up JavaScript alert box to prove we can execute JavaScript on the website to extract information from the website user session. How your JavaScript payload gets reflected in a target website cookie will determine the payload you need to use To explain this, click the this aim. Okay, level 5 from level 6. I'm gonna have to make it a level 6 first. Is this? This is also a machine. Oh, it's not even Okay. Let's start. You're presented with the form asking you enter your name, and once you enter your name, it will be presented on a line below. For example, if you view page source, you'll see your name reflected in the code. Instead of entering your name, we're going to be entering the JavaScript payload. Okay, instead of entering your name, we're going to be entering the following JavaScript payload. So this is a simple one. It's pretty much just once you put it in, it's going to affect the line of code that's there. Go to level 2. So that one was simple. One of those most simplest code way a hacker could get into your shit just by placing some code so it can be interpreted. That should never happen in a website. All right. Like the previous letter being asked to again to enter your name, this time when clicking enter, your name is being reflected in an input tag instead. Viewing the page source, you can see your name reflected inside the value attributed of the input tag. So hello input value Adam. It wouldn't work if you were to try the previous JavaScript payload because you can't run it from inside the input tag. So we need to escape the input tag first so the payload can run. You can do this with the following payload. The important part of the payload is which closes the perimeter, right? So these quotations right here, if we look right here, we won't have, well, whatever we input is going to be in between these quotations right here. So by starting with quotations, we're closing it, and now our code will run because we close the quotations. This one's also pretty simple. I go to level 3. Level 3. You're presented with another form asking for your name, and the same as a previous level. Your name gets reflected inside a HTML tag. This time, the textura tag. We'll have to escape the textura tag a little differently from the input one in level 2 by using the following payload. Okay. This into this. The important part of the above payload is textura, which causes the texture element to close so the script will run. So I'm actually not familiar with this. This is my first time seeing it, but I also haven't learned JavaScript, so I can't, yeah. So I'm not too familiar with this. Now when you click enter which causes, so I think it's pretty much just the same. Like I guess however however you say this shit, however this code runs, it doesn't involve quotation marks. So I think it does pretty much doing the same thing as the last time. You're closing it just however this code runs. Now when you click the enter button, you get an alert pop up. String. So they're pretty much just babying it through us right now, giving us the the answer. Not giving us the answer, but I mean, yeah, giving us the answer. Go to level 4. Level 4. Entering your name into the form, you'll see it reflected on the page. This level looks similar to the level 1, but upon inspecting the page choice, you'll see the name gets reflected in some JavaScript code. You will have to escape the existing JavaScript command, so you'll be able to run your code. So you can this with the following payload: alert Atom, which you will see from the below screenshot. The quotation closes the field specifying the name. Then these signifies the end of the current command, and then the slashes at the end make anything after a comment rather than. So if you know JavaScript, if you learn JavaScript, this will be more familiar with you. The only language I've started to learn is Python. So with Python, the quotations, how it was up above here, the double quotations and the single quotations, they both work the same. It's just if you have a longer piece of code, you want to do a single or, but yeah, most coding languages have similarities, but I'm not familiar with these slashes. Make anything after a comment rather than Okay, so I guess for JavaScript the slashes make it a comment, but for Python it's going to be a hashtag which makes it a comment. Okay, so if we look at the code now, you can see the single quotation stops it. Then you have this signifies the end of the current command. Then you run the command. Then you do the slashes to make it a comment at the end. Okay, so they did the slashes to get rid of that last quotation mark because that last quotation mark would mess up the code. See, this is why it's good, like, even if you're not a programmer, like, just being a pen tester, knowing languages, because then it can help you just. Because programming's hard. Just coding all day, that shit burns you out. And it's good just trying to understand this stuff, even like, because I don't know JavaScript, but I'm using my context clues, right? Just using context clues and what I know in my brain to add things up and learn more, right? Level 5. Now this level looks the same as level 1, and your name also gets reflected in the same place. But if you try script alert payload, it won't work. When you view the page source, you'll see why. The word script. Okay, let me see. This level looks the same as level 1. Your name also gets reflected in the same place, but if you try the script alert, it won't work when you view CY. I'm trying to see. Alert THM. So when you put this code in, the script doesn't appear. The word script gets removed from payload because there's a filter that strips out any potential dangerous words. Okay. When words get removed from a string, there's a helpful trick that you can try. Script alert. Oh, original payload. Text removed. Final payload. So you put a script inside a script. Okay. Whatever you gotta do to fucking infiltrate the. Try entering the payload, then click. Whatever. Yeah. So. See, like something like this is really simple. Like whoever is on the defensive side of security, they put something to get rid of the script, but they didn't think ahead, so it's still getting hacked into. And that's why there always be a job for security and defensive, going back and forth. Level 6. Level 6 is gonna give us the flag, so let's get this done, man. Similar to level 2 where we had to escape from the value attribute of an input tag, we can try but that doesn't seem to work. Let's inspect the page source and see why it does that. You can see that the character, the anywho, I don't know the names honestly. A little rusty. Characters get filtered. I'm rusty from coding, I would say. Characters get filtered out. What the? Characters get filtered out from the payload, preventing us from escaping the IMG tag. To get around the filter, we can take advantage of additional attributes of the IMG tag, such as onload event. The onload event executes the code of your choosing once the image specified in the SRC attribute has loaded onto the web page. Let's change our payload to reflect this. So /images/cat, and then viewing the page source, you'll see how this will work. So SRC script alert. Okay, I bet. Then viewing the page source, see how this work. So /JPEG onload. Now when you click the enter button, you'll get an alert pop up with the string THM, then you'll get a confirmation. Whatever. Is it already here? I don't think so. So I don't know why Tryhackme loves their cats. It's definitely not here though. Alright, we complete the last one. The last one just removes the arrows. So we do this one instead with the slashes. And then we get the flag. So pretty easy. They pretty much baby walked this through us, which I'm glad they did because I don't know JavaScript. So, if they didn't, it would have been bad. Alright, and then we have I wonder if this is a different box. Let me just close this out. And I will start the last machine. Practice example. Is my fucking shit starting? Let that load. Alright, for the last tech, we'll go over blind cross-siding vulnerability. Ensure you terminate the previous machine, then click on the green. Alright, did that. HEB lag. Click on customers tab. Navigate. Okay, so we'll just wait for this to load up. Show you on my typing speed real quick. Fuck. Get nervous. Fuck. I get nervous in a crowd. Fuck. Whatever, bro. I'm not good typing in front of people. No, that shit better have loaded up. Alright, it's loaded. Alright. Terminal loaded up. We gotta go Firefox. Alright, and then you gotta go here to copy and paste shit on the actual terminal. Copy. Hey, bear with me. These terminals can be pretty slow. It's super annoying too. I hate this website, bro. Not Tryhackme. This, but they always make you go to this IT support one. Click on the customers tab on the top navigation bar. I bet. And click sign up here. Ugh. Link to create an account. Once your account gets set up, click support tickets. Alright, so I gotta create some random ass account. Yes, this is my personal Gmail, Matt@gmail. So if you want to hack me, some random ass fucking shit, bro. Sign up. I bet. Now. Go to support tickets tab, which is a feature we'll investigate for the weakness. Try creating a support ticket by clicking the green ticket, enter the subject content of the word test, and click the blue create. Alright, hang on. The green. Okay. Matt. Then click word, just the word. I think they want me to do test. I think they want me to do test. I don't know. I don't want to mess it up. And then click the blue crate, and you'll now notice your new ticket in the list with the ID number, which can take you to your newly created ticket. Like task 3, we will investigate how the previous entered text gets reflected on the page. Upon reviewing the page source, we can see the text gets placed inside a texture. Okay. How do I? And then if we go to view page source, see if we can find this. But I don't like going to the page source on this because I feel it's not the actual page source. It's a virtual machine, so it is, but bro, there's always something off, bro. I swear. Like test 3 will investigate previously reflected. Upon viewing the page source, we can see the text gets placed inside inspect. Okay, I found it. I never mind. I had to inspect the text, right? You can see the texture right here. I don't want to go full screen because it's super annoying, but you can see that we found it though. Let's now go back and create another ticket. Let's see if we can escape the texture tag by entering the follow payload into the contents. Okay, support tickets, create ticket, test 2, and then we just copy this and see. And I'm not familiar with the text Tara one, like I said earlier, so I would have to get ChatGPT if they weren't giving me the code right now. And nothing wrong with that. That's why you use your resources. ChatGPT is like your professor. Create ticket. We just created test two. Again, opening the ticket and reviewing the page where we successfully escaped the texture tag. All right, let's check it out. See if we. That's fine. Okay, well the texture is a different color now. So let's do this. Is that even it? I wonder if that's even my code. See, this shit does not look the same, but it'll be fine. It'll be fine. Now let's expand this payload to see if we can run JavaScript and confirm that the ticket create feature of the cross-sighting attack. Try another ticket with the following payload. All right, whatever. All right, create ticket. Now, when you view the ticket, you should get an alert box with the string THM. We're going to now expand the payload even further, increase the vulnerability impact because this feature is creating a support ticket. We can now reasonably confident that a staff member will also view the ticket, which could get to execute JavaScript. Some helpful information to extract from another user would be their cookies, which we could use to elevate our privileges by hijacking their login session. To do this, our payload would need to extract the user's cookies and infiltrate to another web server of our choice. Firstly, we need to set up a listening server to receive the information. Using the attack box, let's set up a server using netcap if we want to. If we want to netcap, looks like we'll get netcap going. We will issue the command. This should already have netcat on it. Dash p. Alright, bam. Is it going? I think it's running. I think it's loading at least. The L option indicates that we want to use netcat in listen mode, while the TAC P option used specifically on the port number to avoid the resolution host names. Can add the N moreover to discover any errors running netcap verbose. The final command becomes NC, right, which is equivalent to this. I don't need to do that. I don't know why the terminal is not responding. There we go. See, that's what it should have done in the original. I don't know why it wasn't responding. Alright, listening. Now we set up the method of receiving. Let's build the payload. Let's break down the payload. Text arrow tag closes the text area field. Script tag opens an area for us to write JavaScript. Fetch command makes the HTTP request. URL is either THM request catcher. Port number, right? Cookie, the core string. Now create another ticket using the above payload, making sure you swap out the... Okay. URL, either THM request catcher or your IP address from the THM attack box. I bet. Alright, we can work with that. Bro, you see the lag on this shit? Support tickets. We gotta create another one. Let me make sure this shit's up here. Alright, why is it doing that? Hang on. That's gonna be an issue. We might have to go full screen. Alright, let's go full screen. Alright, we have netcat running right here. I bet. Alright, we create the new ticket. Test 5. Alright, let's get this payload going. Command C. Command V. Let's do copy. Let's go back to full screen. No, let's go here. Alright, well, that's not the fucking shit I want. Alright, this isn't even it. I can't do it here. Clearly two different screens. Copy. There we go. Copy. Alright, let's get this payload going. Test 5, final one. Fuck! I fucked up, bro. Dumbass. I did it wrong. Oh my god. So fucking annoying. I forgot to change the IP. Alright, port number. Alright. And just so we can double check our work, I am gonna run it through the code through chat GPT, because it does look a little confusing. Alright, we gotta get our IP from the attack box. 1010 159 29. I mean 52. 10 10 152 29. That's shit what it looks like, but I'm gonna run it through here first. Copy. Hey, if you can double check your work before doing it, might as well. As simple as that. Okay, you can't. Okay, you can't fucking help me. Stupid bitch, bro. Bro, this is why I hate Tryhackme, bro. Deadass. But you know what will work? Fucking what is that Microsoft bro. What is the window? Microsoft. Oh, Copilot. It's called Copilot. I bet. Hey, Copilot will run my fucking ethical hacking shit. Bro, they patched it. I have to run the code. I think the code is right though. That's insane that they're not helping me. We should be alright. I just created the ticket. No, you main counter. I variable setting up. Well, let's see if did we get a hit. I don't think we got a hit. That's bullshit. Is it listening? Alright guys, so I spent about, I don't know, 10 to 20 minutes trying to figure it out on my own. Couldn't figure it out. Well, I figured it out. I know the code I need, but I don't know if it's the virtual machine or I'm not sure what it is, but the netcat is not responding to me. So I know I did it right. I just maybe I did it wrong. I don't know, but I'm not getting a response. So I don't know, and it's getting late. Um, but so pretty much what it's gonna do is it's gonna send you something in base 64, and then you just have to decode it. If it worked properly, I would get something in base 64, and then I would go on a website and decode it. And I'm just gonna go to someone who already did it because I know I did it right, but I don't know. I can't tell you what's wrong. And this will be the answer. If I could get it before we can go to the website. That's what we can do. I can quit this machine. And that's the room. But we can go to this website still. Let's decode. No, I want to encode. Oh no, we gotta click encode. Wait, no, we got it. Oh no, we got it. Yeah, we gotta encode. Let's see if it comes out to the same thing. Encode. Boom. This might be a one way. I don't remember. Switch. Then we go to decode. Decode. Okay, no, it's a two way. So we decoded it. Usually go to a website like base 64 decode. and base 64 encode and decode. So we pretty much just decode the answer and re-encode it. But yeah, if it did work properly, I would get a response on the netcat. I don't know what's wrong with the netcat though. I can't tell you. I'm sure I did it right. I could have did it wrong, but yeah. That's the room. Hopefully y'all enjoyed. Hopefully you learned something. I definitely learned a lot, but you know it's definitely depressing when you can't finish the room off strong with something like that. But yeah, it happens. Yeah, hopefully y'all learned something.